Well, good morning. This morning we're going to look at the LabVolt central office simulator, and what it does is simulate the type of digital switch that you'd find in a telephony office. So here we have it over on my right here, and in this box we have basically all the essential ingredients of a telephone switch, a modern digital telephone switch, similar to, for instance, a Northern Telecom DMS 100 or DMS 250. So basically all the software is in the box. And then on the outside, we have a simple interface to two telephones. And these telephones in the real world would be in your home, but this is just connecting your phone, for instance, to the CO. In real life, there'd be a long telephone cable from your home, twisted pair of wires that would go several miles, and it would basically, essentially connect into the telephone exchange. So what we're going to do here is we're going to show you various things that happen with a telephone call. And on the screen here is the software display of the LabVolt central office, and you can see basically it shows you that you've got the interface to the two telephones. The red phone is the first phone, and then the blue phone is the second phone, and then you've got your signaling circuit, and then your digital trunk interface. Now we can blow this up by using this control here, and actually in software what happens is it shows you in detail the interface to that first phone. So the first thing I'm going to demonstrate is I'm going to demonstrate what happens when you go off hook. In other words, when I left the telephone off, what you're going to see here, the central office normally puts 48 volts across the line here. I can see that with a scope. The software has an instrument here called the oscilloscope, and what I'll do is I'll connect the oscilloscope across the line here, and we can just confirm that we do see the 48 volts. Now I've got to find one of the probes. There's the probe. So let me take the probe, and I'm going to put the probe over here. Okay, and then we're going to turn the scope on. Continuous refresh. I'm going to go to DC voltage. And there, what we can see is we've got about minus 48 volts sitting on this telephone line here. And that's what normally happens in a central office. It puts 48 volts on the telephone. Notice that there's no current drawn. So when I take the telephone off, I'm going to remove the telephone from the handset now. You can see that the current has gone up to about 36 milliamps. So basically what's happened is I've gone off hook. The resistance of the telephone is across the line. That 48 volts now is dropping across the resistance of the wire into the phone and coming back. So that's the first thing I want to demonstrate with this. Now the next thing I want to demonstrate with this is I want to demonstrate what happens when one phone rings another phone. So what I'm going to do is I'm going to move, I can actually leave my probe there, and I'm going to look on the scope here. I'm going to move the time base up a little bit. And what I'm going to do is I'm going to ring the phone, and we're going to see the ringing voltage on the scope there. So let's see, 5551001. And now I'm ringing the phone. So what's happening is the central office had a call coming in that wants this phone, so now he puts a ringing voltage on that phone. So basically what you're going to see is 90 volts plus or minus sitting on the minus 48. And let's see if we do see that. There's the minus 48, and we're going to be able to see the ringing voltage. There it is, sitting right on top of that neg 48. Okay, so there's the ringing voltage sitting on top of the minus 48. So you can see it again. There we go, and there's minus 48 and the ringing voltage, plus or minus 90 volts from that. Now, when I pick up the call, what happens is the central office detects the current going in the line, so it immediately disconnects the ringing voltage, because you don't want to send ringing voltage down a phone that's now off hook. So what we're going to do next now is, now that the call is established, I'm going to move this scope probe over here, and what we're going to look at is we're going to look at the voice, my voice signal on the scope. So I'm going to speak into the phone here, and hopefully we'll be able to look at my voice on the scope. So what I'm going to have to do now is go into AC coupling and bring this down a little bit. Testing 1, 2, 3, 1, 2, 3, 1, 2, 3. There we go. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. And now you can see my voice on the scope. That's the voice being received from the scope. Alright. Now, what we're going to do now is we're going to follow this signal through, and we're going to look a little bit further down the line here. So, the voltage from your phone is an analog voltage. It comes in here into what's called the SLIC. That's the subscriber line interface circuit. And what happens there is that voltage goes into a codec, and now it's converted into a PCM signal. So what we'll see coming out of here now, if I move my scope probe, I won't see an analog signal anymore. I'll see a digital signal coming out on the scope. So let me keep talking. Alright, and we're going to put this into digital here. Yep. So now what we're doing is we're seeing PCM bytes, pulse code modulation bytes, coming out of the phone. And of course the combination, the code assigned to my voice, keeps changing as the amplitude of my voice goes up and down. I get a different PCM code coming out of there. But what you're seeing is pulse code modulation coming out of there on the telephone. Alright, now if we wanted to, we could also show as well, you could have several telephone conversations going on, several telephones interfaced to this box. They're all producing their own PCM codes, and then what you can go show further on is you can show how all these codes are added in different time slots, and they make up the complete picture of the PCM leaving leaving the central office switch. It's multiplexed into a T1 signal where you can have 24 channels doing that. So that's basically it.